Hi everyone, let's solve the second question from today's weekly contest, that is minimum operations to reduce an integer to 0. In this question, you are given a positive integer n and you can do the following operation any number of times, that is add or subtract a power of 2 from n. Then doing this operation, we have to return the minimum number of operations to make n is equal to 0, right? So the question is pretty straightforward. All that we have to do is we will be given an integer and we can either take any power of 2, right? And we can either add it or subtract it to this particular integer n, and this is adding it or subtracting it is one operation. So we have to calculate the minimum number of operations to make n equal to 0, right? So if you see the first test case here, they have written that you can add 1, then you subtract 8 and you subtract 32. So in these three operations, these are the minimum number of operations. 3 operations will be taken to make this n to 0, right? Here it has become 0 and they have showed us that how it has become 0. Now let's see. Now let's see what else can we do. So is there only this way to do it? Is there only this way to do it? Now if you, okay, so first let's write down the powers of 2 here. 2, 4, 1 is also a power of 2, 1, 2, 4, 8, 16, 32 and 64, right? So these are the powers of 2. So now let's see, we have 39 here. Let's try to build an algorithm. What we can do? So if we can somehow take a power of 2 and try to minimize the difference, whether it's greater than 39 or less than 39, we have to consider a power of 2, so that when we get the difference, right, that is what we mean by adding or subtracting. So here we will only subtract either by a power greater than or less than. So if you are subtracting from a power greater than, that means you are adding that particular number. If you are subtracting a power that is less than this particular number, then you are subtracting it only, right? So what we will do, we will consider the difference, right? So what we'll say, we will take a value that is a power of 2 that is nearest to this n, right? Only then our difference will be minimized, right? So if we see 32 is that number which is the most nearest to 39, so what we'll do, we will calculate the difference, right? So we'll say subtract this 32 from 39. What will we get? We will get 39 minus 32, which is 7. Now what we will do, similarly for 7, right? Similarly for 7, we will find a power nearest to this particular value. Nearest to 7, what do we have? Here we can clearly see 8 is nearest to 7. So what we will do, we will calculate the difference between 8 and 7, which is 1. Now, if you see, we have 1 here and we also have another 1 here. So if we just subtract this, it is equal to this particular number, right? So if we subtract it, what we will get? We will get 0. So we have taken 3 operations to make n 0, right? Let's take another test case. Let's remove this. Let's take another test case. That is the second one, which is in the question is 54, right? Let's take 54, right? So what we will do, we will consider the value which is nearest to 54, that is 64. So we will say 54 minus 64. What we will get? We will get 10, right? Then we have 10 here. What we will do again? We will consider a value that is nearest to 10, that is 8. We will again subtract it. We will consider its difference. We will get 2. Now the value nearest to 2 is 2 itself. So we will subtract it. What we will get? 0. So here you can easily see that within 3 operations, we have made 54 0. So I hope the intuition is clear to you. Now let's see this in action, right? Let's see the code. So that is only thing that I have done. So I have created a different function here, right? It calculates the value that is nearest to this particular, to the particular number that we have, right? So what we have done here, we have created this powers of 2 vector. So here we have created it. We have created up till I is less than 16 because we only have values that are less than equal to 10 raised power 5. So at most we can have 16 bits. So we have created these powers, right? And here we have simply calculated the minimum difference that we wanted, right? Calculate minimum difference. And here inside of this loop, we are saying n is equal to this particular value, calculate minimum difference, right? So this is what we will be getting for each iteration, right? For 54, right now n is 54, but when we will go inside of this function, what will we get? We will get 10, 54 minus 64, that is 10, right? So our n will now become 10, and we will do it until n is not equal to 0, and simply we will calculate that how many times we had to call this calculate minimum difference function. That will be our answer. So that is how you have to solve this question.